All right, guys, let's start chapter 10 now. Chapter 10 is all about parametric functions and parametrized curves, and of course, doing calculus with these things. So the first question is, what the heck is a parametric function, and what is its associated parametrized curve? So I'll write the definition, and then we'll look at some very simple examples, and we'll work through some more examples as we go through the notes. But a parametric function, first of all, a parameter is a variable that's not going to show up in our axes, okay? So a parametric function is a function of the form, for us, it's going to be a function which we'll call f of t, okay? And it's actually going to be kind of a combination of two functions. This function f is going to tell us how x changes with respect to t. So it's going to be one function of t in the x direction, and how y changes with respect to t. So, and in this situation, what we think of is that the domain of this function is obviously the t coordinate. So the domain is a single real number, so a t value, and the output of this function is really two different numbers, so two coordinates. So we think of it as a point in the plane. All right, and so in the xy plane, here's the idea. If we plug in a certain t value, say t1, then f of t1 might be a point over here. So this f of t1 is the point x of t1, comma y of t1. And as we change t, maybe to t2, then this point, both coordinates of this point change. There's a change in the x direction. There's also a change in the y direction. And so maybe the new point is right here. Okay, so this will be f of t2, and of course the output here is a point x of t2 and y of t2. Now I'm writing this all in point notation, but we've already studied chapter 12, so we can think of these outputs as vectors if we want. Okay, so we can think of this as a function, a parametric function, as a function that takes in its domain, it takes in a real number, and then it outputs a vector in two-dimensional space in this case. And you can probably think of exactly how this would extend to 3, 4, 5, 12 dimensions. We'll stick with 2 dimensions for now. But if you want to write it this way, then we could think of this vector as the output as opposed to the terminal point of the vector. Either way is fine. The book hasn't done vectors yet, so they're going to do this as points. But since we do have this intuition of what it means to be a vector, then another way to write this same function would be to write it in vector notation. Just group together the x and the y outputs into a single vector and think of it as a vector that changes with t. When we do this now, we usually rename the function and write it in vector notation, and so we usually call this r with a hat. Why r, I'm not so sure, but r with a hat. So that's vector notation, and now the output here is going to be the vector whose coordinates both depend on that input t. So r of t equals x of t, y of t in vector notation. Okay, so a vector, in this case, this could be called a vector function, and this vector function is really just a parametric function that's been combined into a single vector. And so when you get to Calc 3, you'll definitely want to think of them this way. So we'll introduce the notation right now, but it's not going to hurt us to think of it either way here. So either as points or as vectors. The question now is, how does this parametric function work? And so the idea is that if we have a single input space, so t, this is the parameter space. So this is called the parameter space because you don't see the parameter in the graph of the function. We're going to talk about the graph right now. But this is called the parameter space, and again, it's just a single real number for us. And in physics, they frequently think of this parameter as time. So that's where the t comes from. So t can be thought of as time. And then in the output space over here, I'll put it over here. So the output space, the output, there's a twofold output. There's a change in the y direction, and there's a change in the x direction. Okay, and these both depend on t. So here's the idea. So we start at, say, some t value, and maybe that corresponds to x of t over here, and maybe y of t is up here. Okay, and so if we put that all together, then this output has to encode both pieces of information, where the x coordinate is and where the y coordinate is for this input t. And so there's a starting point. And now, this is calculus, of course, so think of a tiny change in the t direction, so like a delta t. Now, as t changes, as you have a tiny change in t, the x and the y coordinates are both going to change as well. So let's say when t changes this much, whatever this is, again, you think of this as a small change if you want, or it can be a big change for what we're doing right now. That's fine. But as this t changes, maybe x just changes a little bit. So maybe x only changes this much, but maybe y changes a whole lot. So maybe y changes much quicker than t changes, and x changes a little bit slower than t changes. And so the result then is going to be, well, the output point from all this is going to be like around here, right? And in between there, as long as this parametric function that's doing this, that's mapping this parameter t to the output space, as long as this function is nice, and again, we're going to do calculus, so we're going to want it to be continuous and smooth and have all these nice properties. As long as it's doing all those things, then this curve is, these points are actually going to change along a curve, and maybe they change like this. Okay, maybe the curve looks like this. So as x and y change, it traces out this portion of the curve. All right, and as we allow this to happen over the entire domain over here, the entire domain space, then what gets traced out is a parametric or a parametrized curve that corresponds to this function f. All right, and as we move forward with these videos, we're going to look at lots more examples of parametric curves, and of course we're going to then do calculus on these parametric curves. But for now, this is the basic idea of what a parametric function and a parametric curve are doing, and how it's different than the kind of functions and curves that we're used to.